Hello, everyone. My name is Mitsu Ganley. I'm the Director of Marketing here at Lumina Decision Systems, the makers of Analytica. We're really thrilled to have Justin, Brian, and James with us today for navigating the heat pump landscape, helping consumers, utilities, and cities make economic decisions. Justin Spencer is a professional engineer and works as the project director with Apex Analytics. For the last 15 years, he has consulted on energy efficiency programs for utilities, cities, and states. Brian Thull is the Energy Service Supervisor for Fort Collins Utilities and leads a team of utility professionals. Fort Collins, Utilities is prioritizing the integration of distributed energy resource programs for residential, commercial, and industrial customers and seeks decarbonization strategies that improve the community's equity and resilience. James Milford heads our Lumina consulting team. James has more than 14 years of experience using Analytica for energy and environmental modeling research and consulting. James, I'll let you take it away.
Okay, well, thank you, Mitsu, and thank you for everyone for attending. I think we have a good lineup today. And before we dive into slides, I just wanted to give you like a picture of how our three organizations relate to each other. So we're going to talk about two case studies today. The first will be one primarily performed by the city of Fort Collins and Apex Analytics, looking at the cost effectiveness of different electrification strategies. And as part of that, Apex being kind of leaders in helping utilities navigate analysis and road mapping of demand side management programs. Apex reached out to Lumina for some assistance creating a tool that they use for this particular engagement. And the second case study that we'll be talking about is one in which Lumina and the 3CE, which is, I always forget this abbreviation, but the Central Coast Community Energy out of California. Lumina and 3CE work together to kind of help advance adoption of electrification, and that required us to build some websites and tools allowing their customers to evaluate bill savings. So we're going to dive in with that first case study. I'm going to hand it over to Brian, and I think Justin's going to chime in also midway through. And as Mitsu mentioned earlier, please interrupt us with questions through the Q&A or raise your hand.
Yeah, thanks, James. Hi, everybody. Super happy to be here. Thanks again to Lumina for hosting this. Again, my name is Brian Thull with Fort Collins Utilities. We're about, for those of you unfamiliar with Colorado and the Front Range, Fort Collins is about an hour north of Denver. And we have a population of about 175,000 folks here in Fort Collins. It's a college town. Colorado State University is here. And we have a municipal utility, Fort Collins Utilities. It's a 5-service utility with water, wastewater, stormwater, broadband, and light and power electric service. So a little bit about us. Generally, we have very aspirational climate goals, very progressive community and city council here in Fort Collins, with targets of 80% greenhouse gas reduction by 2030, 100% renewable electricity by 2030 as well. And we're well on the way to achieving those targets. We're over 50% non-carbon generation resources here on the electric side, and forecasting to be about 45% GHG reduction by 2026. So That goes across all categories, and we're excited about that. And also just a big commitment to, climate action, 20+ year climate action plan. Most recently, we updated our climate action plan to include or to be centered in equity, leading with race, and focused on kind of that MRE, mitigation, resilience, equity nexus. Bit more about utilities that help set the stage for some of our cost bend work. We do have relatively cheap electricity out here, blended rate of about 11 cents per kilowatt hour. We do have a default residential electric rate for all 68,000 residential premises, and with pretty aggressive off-peak versus on-peak ratio of about 3.5x. So about 7 cents off peak and 24 cents on peak. So certainly helps with a lot of our current cost bends, and but it makes it pretty challenging to evaluate things on peak and off peak, which is why we solicited Apex analytics and the use of Analytica to do some of this cost effectiveness work. So getting into it, again, Fort Collins Utilities is looking for a way to help achieve the GHG reduction goals. So it's a largely carbon focused analysis, where we are essentially not deciding if we do electrification, but how do we do electrification? So the work that Justin and I were working on was essentially to prioritize and select electrification measures. Now, being a municipal utility, we don't necessarily have to be cost effective at the measure level or program level, but rather we evaluate cost effectiveness at our portfolio level. So from a demand side management perspective, over the years, it's given us a lot of flexibility to introduce new programs that help our customers achieve decarbonization. So again, how do we select? How do we prioritize? That's where this solution that we're talking about today comes into play. This community-specific cost effectiveness framework that we developed, which ultimately led to a roadmap for the implementation of our programs. So, at a very high level, this roadmap was essentially prioritizing kind of the highest impact items. And we'll get into that soon. And what we wanted to do was essentially, again, prioritize our programs for the way to achieve kind of the low-hanging fruit from an electrification standpoint, but also to really call out places to avoid as well. And I won't steal Justin's thunder much, but as we, in 10 or 15 years, we forecast to become a winter peaking utility. We're still summer peaking currently, but how does that change over the years? How does the cost effectiveness of measures, how are they impacted? And what are some of those measures that we want to avoid from that perspective? So part of the analysis, we cast ahead to 2040 to really look at, in 100% renewable electricity future, where are our biggest opportunities for GHG reductions? So we really broke this down into new and existing residential end uses, and see through this analysis that the biggest bang for our buck is really related to space heating and water heating in the existing building stock. We define that as essentially 2021 and forward would be kind of our new building stock. We're on the IECC 2021 code and energy codes right now. So we have a few other levers to pull when it comes to new construction. However, again, this framework and this analysis really showed us that we should be focused on electrification measures and programs in our existing building stock. And this was generally our approach to help get us to the place where we want to launch new electrification programs. We did some benchmarking on some current electrification programs across the country, and I've learned a lot from our peers along the way. We surveyed our local contractor and customer base on their awareness around heat pumps that I'll share in a minute, and ultimately developed this cost effectiveness framework to help us implement, resulting in some of these key recommendations for what our program will look like once launched. So I won't focus on the benchmarking initiative related to electrification measures, but before handing it to Justin, I did want to mention some of the awareness of contractors was actually more so than we thought. So we had a few key contractors that were aware and did view heat pumps, specifically air source heat pumps, as an opportunity in Fort Collins, and really did talk about focusing on our customers with solar as a potential target for selling heat pump technology to. On the customer side, we didn't see as much awareness. However, we did see a willingness to learn more. And interestingly, they had only indicated that about 10% of bids from contractors did include heat pump options when evaluating space heating and cooling. So very interested customer base, but low awareness from that perspective. With that, I'll go ahead and turn it over to Justin to dig a little deeper into the cost effectiveness framework. And there you go.
Okay, can folks see that okay?
Yes.
Great.
Yep.
All right. So as Brian mentioned, this is what we were tasked with, was trying to figure out, how might we best achieve some of these building electrification goals in Fort Collins? So what are we trying to pursue now versus in the future? And to do that, we had to try to prioritize different electrification measures. So the problem we had was that building electrification is a little bit different because electricity consumption increases, right? We're used to energy efficiency testing when we're always reducing electricity consumption. However, in this case, we're actually going to reduce gas and increase electricity consumption. So some traditional benefit cost approaches just aren't going to work very well in this context. So the solution that we employed was to follow the National Standard Practice Manual guidance for developing a jurisdiction-specific test. Then we worked with a hand-picked group of stakeholders within the utilities and to develop this test. And then we worked with James at Lumina to develop this JST compatible, flexible cost effectiveness tool in Analytica, which offers some specific benefits. So here's just a quick overview on this tool. The key features from our perspective were that it was very flexible and transparent. We developed it with Lumina, and then it was easy for us to implement these NSPM jurisdiction-specific changes to tests, right? So if I wanted to add or subtract a particular benefit stream or cost stream, we've basically set the tool up to be flexible and easy to do that. So that was one of the key things that we were asking James to do. The other key thing that we were trying to do is figure out a different way of expressing our test results. So while we have some of the traditional outputs, like a total resource cost test, a societal cost test, a utility cost test, participant test, a ratepayer test, so a non-participant test, we also wanted to add in this this thing that's essentially the marginal cost of carbon savings associated with this. So rather than trying to, this basically allowed us to, instead of trying to specify a specific price of carbon and say, oh, well, this is the cost effectiveness of different things relative to that price of carbon. Instead, it allows us to rank order everything based on the implied cost of the carbon reductions achieved by that measure. This was also a nice feature for this context, which is really focused on trying to attain the largest greenhouse gas savings that we can for the smallest investment. And it allows us to compare across any kind of greenhouse gas reduction. So it wouldn't have to be just within an energy program. It could be other things that they might try, like planting trees, or I don't know what else, right? But you could compare. So in terms of the flexibility, this is sort of an example of how that works. We have this master table within the tool that has all the different cost and benefit streams, and then you can choose for each cost test how to treat it, right? And so this was a big plus for us. So first we developed the framework, we developed the tool, then we had to do some modeling of heat pumps, because as Brian brought up earlier, when we looked at the opportunities, it was really all about residential space heating. So I wanted to talk a little bit about heat pump operation and some of what we found there. So for starters, this is a bin analysis of when the loads happen, what temperatures different heating loads occur in Fort Collins. So Fort Collins has a cold, dry, sunny climate in the winter. So you actually see the bulk of the heating load happens between 20 and 40 degrees, so right in the heart here. Yes, it can get extremely cold, right? I think the all-time record cold temperature in Fort Collins is 35 below or something like that. It does get to 20 below, once a decade kind of thing, at least in recent years. But as you can see from here, that like the fraction of the heating load actually being delivered below zero is very, very small, right? That's very rare weather. But when you do get it, you can get a few days in a row where it doesn't even get to zero, right? Very cold but infrequent. Whereas your typical weather is like a low of 20, high of 50, sunny day in the winter. All right, this is the big one. Let me step you through how this works. So the operating economics of heat pumps depends on the price of gas and electricity and the efficiency of I guess it's the price of fuel versus the price of electricity. In this case, we're talking about gas, and also the particular temperature that you're at, because the efficiency of the heat pump drops as the temperature drops. And so on this plot, you basically have on the y-axis, we have the outdoor temperature in degrees Fahrenheit. And then on the x-axis, we have the ratio of the electricity price in cents per kilowatt hour to the fuel price in dollars per MMBTU. And this particular plot is for a standard heat pump against a standard furnace. So 80% furnace, 14 SEER, 8.2 HSPF heat pump. And so to find where you lie on this plot, you basically, you find the temperature that you're at, and then you find the ratio of your gas price to electricity price. So when we first did this analysis, Fort Collins was right in here, right? We had $8 gas, 8-cent electricity off peak. I guess I rounded up. Brian said 7. I was saying 8, but 7-point-something cent electricity. And so we're at a ratio of about 1, right? And so then if I want to find the temperature at which I have cost parity, at the point at which the price of the heat pump provided heat and the price of the furnace provided heat are the same, it's right where I intersect this zero line. So the dark gray line is the zero, the point of cost parity. And so for my ratio of 1, I come right in here at 20 degrees. So what that means is at any temperature above 20 degrees with that particular price, it's more cost effective to heat with the heat pump. At any temperature below 20 degrees, it was more cost effective for the customer to heat with gas. Now, if I then fast forward to today, kind of show you the range of what can happen and how influential the rates are. Right now, gas prices in Colorado are up to about $12.50 per MMBTU. So they're much higher than they were. And Fort Collins has off-peak electricity at 8 cents a kilowatt hour and on-peak at about 25 cents. Again, I round it up, Brian rounds down, it's okay. And so what happens then is from this initial point, we now have, if you have much more expensive gas, well, now the heat pump operation becomes much more cost effective at a broader range of temperatures. And likewise, when I look at the on-peak prices, it's almost never cost effective for the customer to run the heat pump. So in our particular case, folks really want to prioritize running their heat pump with off-price electricity and then trying to not heat or glide through those evening hours. So then if we flip back to this distribution here, you can see how influential this is, right? So if I'm heating at all temperatures above 30 degrees, that's about half the load. But then if I'm at all temperatures above 20 degrees, that's another 30%. So now I'm able to meet 80% of the load with the heat pump cost effectively. All right, do we have any questions yet on any of this? I can't quite see the questions. We're all good.
Not yet, Justin.
Great. Well, we'll just assume everybody understood all of that. And I explained it perfectly for once. So then the next really important issue around heat pump operation is just what happens during really cold weather. So how do we keep people warm during extreme cold weather? The problem is the capacity of heat pumps drops off as you get to extremely cold temperatures. So you need some kind of backup, at least in this climate, right? We're a cold climate. One option is to use a hybrid heat pump. So use the existing gas furnace. And you have zero grid impact in that case, right? You have no heating capacity required, no electric capacity required to meet your heating loads during those times. Or you can use electric backup, which is what's happening if you're doing full electrification. However, in our case, that's adding about 10 kW per home in winter capacity, which is a lot, right? It's worth a lot. So just to kind of show how this works in practice, that's the plot on the right is a plot of what my heat pump did during an extremely cold day we had last winter. So you see there at about 2 in the morning, the heat pump just stops running altogether. And that's because we hit some kind of low temperature cutout. And the reason for this was that the temperature at my house that morning was about 15 below. Right, so it's extremely cold. The heat pump stopped running altogether. It didn't matter too much in this case because this heat pump heats a conditioned basement that's very well insulated, so the temperature didn't drop that much. And then the sun came out again, and by 9 or 10 a.m. the heat pump was running again, and we were all set. However, this illustrates how this becomes a problem, even for a cold climate heat pump. At some point, you really start to run out of capacity. And that means you've got to either heat with gas for the extra or use electric resistance, which we'll see in a minute causes some other problems when we go to do the measure screen. All right, so now the measure screening.
Really quick, we had a question come in.
Sure.
Is the assumption that households will have dual fuel in the house? For example, gas furnace and heat pump?
Yeah, so we analyzed a whole suite of different measures. So we did full electrification, The assumption is that to start with, people are starting out with having gas or propane for heat, right? Non-electric. We did have a few electric to electric measures, but that wasn't really the focus. In this analysis here, we are talking about a home that has gas to start with and has replaced their air conditioner with a heat pump, if that's what the question's referring to. Which
Great, thank you.
we'll see in a minute is a very important case for Fort Collins. So when we were considering which measures are best, we look at a bunch of things, right? So what we're looking for is a measure that's a win-win-win for the participant, ideally for the non-participant, so it doesn't negatively impact rates, and then is a winner on the community test, and also saves a bunch of greenhouse gases. So we want a winner on the first three tests: the participant cost test, the ratepayer impact test, and the community test. And then we want to make sure that we're attaining some of these large greenhouse gas impacts. And then lastly, we want to look at the winter peak demand impact to consider, well, will this negatively impact our ability to meet electric needs during the winter? So our best opportunity is to replace new CACs with a heat pump. That's what we found. It's the most cost effective. It's good for ratepayers, it's good for participants. So if you leave that furnace in place for cold weather, you can meet all of your loads at whatever temperature you want. And you can save a bunch of money during more mild conditions when the heat pump works well. So the pros of this option, like if I was to ask you what's the difference between the left picture and the right picture, one's a heat pump, one's an air conditioner, and the answer is you can't really tell the difference, right? You have to look inside and really know what you're looking for to find the reversing valve. There can be some other differences involved, but it doesn't cost a whole lot extra to go from an air conditioner to the same exact thing, but equipped to actually also produce heating. So the pros are it only costs about $500. It saves at least half the load. The cons are it's only applicable in situations where someone's already buying an AC. So if somebody's already buying a central AC, we convince them to buy a central heat pump instead, and we can very cost effectively get some significant greenhouse gas savings. This is the lowest hanging fruit that Brian was talking about. So the next key finding, the full displacement with electrification, so going 100% electric, is very expensive for the utility and ratepayers. So as Brian mentioned, we're expecting Fort Collins will become winter peaking sometime in the 2030s, especially as we do more electrification. And each additional kW of winter peak costs around $100 a year to meet with gas combustion turbines even, right? If you're trying to have a carbon-free means of meeting this, it's untold expense. We don't really know what it is, right? You can't actually buy that thing. It's going to be able to provide us with a week of backup. And so when we bring back that present value of 10 kW of electric resistance back up, we get about $17,000, right? So that's the additional cost of the utility to meet that capacity. And so our conclusion here is just that electric resistance backup heat in this climate, in our situation, is a bad idea, right? So we don't want to encourage that with our rebates. At least that's our recommendation. Next key finding, so the heat pump cost effectiveness depends strongly on the air conditioning being worth something. So if somebody doesn't have air conditioning to start with and doesn't want to pay anything for air conditioning, it's really hard to make the case, just an economic case, for getting a heat pump, at least here. That might be a little bit different if you have propane, which is even quite a bit more expensive. But in our case, that cooling really has to be worth something. And in our climate, right, we also get temperatures into the up to 100 degrees in the summer on a regular basis. It gets to 90 like 40 days a year or something. It's a climate where people appreciate having some cooling. All right, so our next significant finding was just that cold climate heat pumps cost a lot, right? This is probably self-evident for folks who've looked at this. But it's really hard to justify. So in the case on the left here, we've got a it's akin to comparing a Tesla Model S. That is an amazing automobile on the left-hand side. It goes 0 to 60 in 2 seconds. Yes, I would love to own one, but the price tag is just not going to happen, right? Whereas on the right, that's a used Model 3. It's still pretty pricey, not really in the budget anytime soon, but it's at least somewhat more attainable, right? And so this is akin to a cold climate heat pump, full variable speed all the time, versus a, just say a high efficiency heat pump, right? And so you can still consider it incenting these some, especially with the 100% displacement options, but you're still gonna have to solve that backup heat problem, at least in this climate. So yeah, just a summary of the key findings. We've already been through most of these, right? It's mostly about space heating and water heating in terms of greenhouse gas emissions in the future from buildings. Full electrification adds a bunch of winter peak. We really have to keep electricity prices low relative to gas if heat pumps are going to be cost effective for customers. We found that the partial displacement measures really looked great. They add a bunch of electricity consumption without adding peak load, which really improves utility load factor, and those benefits can pay for high rebates. So these actually pass the ratepayer test. So if I'm installing a heat pump, a hybrid heat pump that's using gas half the time, electricity there half of the time, I'm going to cause downward pressure on rates from this kind of a program. And then lastly,
another question. Sorry to interrupt you. Related to modeling a hybrid heating system where the gas furnace comes on only during colder weather, did the model assume current gas rates, or did it assume the cost of delivering gas to the home would go up because overall gas consumption is going down?
So the way we modeled this is we modeled a few different switchover temperatures, and then we looked at the cost effectiveness of those. So if you come back to this plot, right, you can operate a heat pump any way you want on this plot, right? Like this is part of why we built something like this, is it allowed us to say, well, if gas prices got a lot higher, then this would be effective, versus if they were a lot lower, this would be effective. So in our analysis, we used current gas prices, but we're doing a follow-on now to look at some sensitivities to different prices of gas and electricity. So right now, based on our conclusions are based on current gas and electricity prices in, or actually last year's gas and electricity prices in Fort Collins, and these were our results. Now you wouldn't necessarily get the same exact result someplace else, right? So if you have really high electricity prices, you wouldn't get that same conclusion necessarily, right? That these partial displacement heat pumps were big winners.
Awesome, thanks. We actually had another question come in, and a response to the question you just asked. So the response to the question you just asked was, how does fuel switching play into this from a regulatory standpoint?
That might actually be a better question for Brian.
Okay.
Brian, do you want to comment on that from Fort Collins's perspective?
Yeah. So at this point, I maybe failed to mention that Xcel Energy is actually the natural gas provider within the city of Fort Collins. So we're only the electric provider. And then you're talking about a muni versus an IOU. And Xcel Energy certainly has different regulatory requirements, and in Colorado is regulated by the Public Utilities Commission. From an electric standpoint, Fort Collins implements programs essentially at the direction of City Council and the Executive Director of Utilities based on city policies. So from our standpoint, there is no kind of regulatory needs that we need to consider when looking at fuel switching.
Yeah, so I would contrast that within some places, you're not allowed to do fuel switching at all, right? Like I think think Washington State, right? It's even written in the Constitution somehow. They're not allowed to do that, but they need to change that. So this varies from place to place for sure.
Wow.
And it's something that's changing rapidly, right? Like in Colorado now, there's an ongoing proceeding that will require everybody to strongly consider doing fuel switching.
Interesting. So we have a couple more questions here. From Max Henrian, our CEO, he's asking, what is the cost of low temperature HP relative to regular HP? Is it really 3 times as implied by Tesla versus the 3 comparison?
Yeah, the 3x is probably a little bit hyperbolic.
Okay.
But it's not that far off, unfortunately, right? Like I've yet to hear of anybody getting a quote for a central variable speed heat pump that was less than 20,000. Whereas you could probably get a plain Jane heat pump for less than 10. So it's not 3x necessarily, it's probably more like 2x. And the other thing I would just mention is that this is going to change over time, right? Like people will figure out, this might get more competitive, et cetera, that might bring the cross premium down some. So This is just where we are now. Cold climate heat pumps are really, really expensive on the central heat pump front. On the mini split front, I don't think the delta is nearly as large. In fact, you kind of might as well go cold climate. We could really get down the rabbit hole there. I want to actually skip ahead and just quickly go through kind of what the phased recommendations are here, and then I might want to hold questions until we get to the end. I see Rich has a really good one, so we'll get to that one in a minute.
Okay, yep, sounds good.
Or no, maybe he already answered that one. All right, so let's just chat. So based on those key findings, what was our recommended way forward? This is not necessarily the way that Fort Collins will proceed, but this is just our set of recommendations. So the first phase here, we're saying you're going to build market awareness, customer knowledge, and contractor capability. So what we're trying to get to is answering this question of what would it take for contractors to almost always install a heat pump instead of an air conditioner? We want that to become standard practice here. And so our recommendation is you offer contractor training and downstream rebates for all heat pumps, not just cold climate. So have really, prioritize these broad-based hybrid solutions. So a heat pump for every home kind of thing. That's what we're trying to do here. Phase 2 is where we open things up, right? So we're trying to get more widespread adoption. We recommend adopting codes for new construction that require heat pumps, that you consider and build midstream offerings. So that means trying to incent things at the distribution level, then trying to improve heat pump economics through rate design. That's phase 2. Phase 3 is when we drop the hammer, right? This is when we use the big sledgehammer that is codes. So you adopt codes to require heat pumps and heat pump water heaters in all new installations, and you make this push towards zero carbon. This is a little ways out, and I think maybe requires some additional work, but we're not going to jump straight to here. We recommend using this phased approach. So I'm going to not take any more questions right now. I'll wait to the end, and I'm going to hand things back over to James to talk about the second example.
Okay, well, thank you, Justin. And are you able to see my screen now?
Yes.
All right, so from Lumina's perspective, we try to specialize in tool development, creating software application that help people make good decisions. And the case study that I am going to discuss is the one with the Central Coast Community Energy. Just as a little bit of background, 3CE is a community choice aggregator. They effectively base their rates off of the same sort of structure as Pacific Gas and Electric, one of the, if not the largest electric utility. And what they're able to do is discount PG&E's rates by, some percentage to make it more attractive to the local communities that choose to buy their energy from 3CE. And they reached out to us to help them accelerate the adoption of electric heat pumps. Our original focus was looking at residential customers and heat pumps for space and water heating. And the contrast between this particular utility and the city of Fort Collins it's very large, right? You've got a pretty moderate climate in the Central Coast. You have very high electricity rates compared to the US national average. And as I'll show in a moment, some of those rates are quite complex. Lots of time of use periods and tiering and so on. So it kind of paints a different picture, but it all kind of points to the need for having robust tools to do these kinds of analyses. So here was the challenges and the solutions that we were tackling. First is how to educate consumers, right? So this goes very much back to Justin's phase 1 approach, making sure that consumers understand what heat pumps are, helping them learn more about it, become more familiar. And really, that's a key starting point for accelerating the adoption. And what we wanted to do was make sure that we could provide the customers of 3CE enough information for them to feel confident to go out and have a conversation with a contractor, to learn more, get quotes, and so on. We also wanted to build a bill savings estimator. So, rates are very complex, especially out in this region. And just understanding a utility bill, it can be very challenging. We wanted to make that completely disappear for the customers of 3CE. We built all of these complexities into our bill savings estimator. And we were trying to make sure that customers could have a tool that'd be very easy to use and give them some of the most accurate results that are available right now through free online bill savings estimators. There's a couple other key points to having a really good bill savings estimator. This is not only useful for the customers, it's also useful for contractors who want to make sure that they're, being reliable advisors to their customers. And from a utility point of view, it's very important to know what are the bill impacts to these customers. If the utility is trying to encourage folks to electrify, it's nice to know whether or not utilities should expect an increase in their bills or a decrease. If there is an increase in energy costs, can the utility provide some sort of incentive or rebate to still make electrification measures cost competitive? And then lastly, if utilities are really serious about electrification, they may need to rethink the rate structures to make sure that whatever rate structure is in place is actually going to encourage electrification. So our solutions to these two problems was one, to come up with an educational website that was available or kind of specific for 3CE's customers. And the other was really a cutting edge bill savings calculator that we embedded in that same website. For the sake of time, I'm not going to navigate to those sites, but I'll give you a quick preview. The educational website, we were trying to accomplish several things. Let people know a little bit more about electrification and heat pumps, explain how heat pumps work, describe the benefits of switching to a heat pump. And there's a lot of different heat pump technologies. And it's not easy to find a single source of information. If you're, really savvy, you know where to look on the internet. you might have to jump around to several sites to get an overview of the different kind of heat pumps. Well, we try to combine that all into one location, make it as easy as possible for these utility customers. In California, there's quite a few rebates and certainly many contractors. So we try to make that information available. And then, just providing videos and other educational material. The heat pump calculator itself, really what we saw when we were looking around in terms of what was available is that there were some free online calculators available, but most of them were very simplistic. Things like only looking at what's your average annual gas price, or what's your average annual electricity price. And in these regions where the electricity prices and gas prices have a lot of complexity in them, things like time of use and tiered rates, you really need a better calculator to figure out how much money you're going to save over time. So we put together this calculator, tried to make it very easy for a common homeowner or a HVAC contractor to use to be able to estimate bill savings based on different building configurations and climate zones, and giving them the drop-down menus for whatever rate they were on. And now I'm going to show you just some examples of some of the rich information that is possible using this calculator. So first we need to talk about, like, well, why isn't a simplistic back of the envelope calculation necessarily reliable for heat pumps and for these different jurisdictions throughout the US? Well, the first challenge is that there are complex rate structures. What I'm showing here is one rate. It's called ETOUC, so it's a time of use rate for Pacific Gas and Electric, and it varies by summer. I have summer on the left, winter on the right, and you'll notice that depending on the day, you're going to see a different price. From 12 to 4, you're at an off-peak period. From 4 to 9, you go into on-peak, and then back to off-peak after 9 p.m. In addition to the time of use, there's tiering, which pretty much says that if you're a high consumer of electricity, at the end of the month, the utility looks to see how much monthly consumption you've had. And if you exceed some threshold, you might end up with a price adder. So in this case, it was a 9-cent price adder if you exceeded the monthly allowance. So these kind of complexities make it very challenging to come up with an accurate estimate of bill savings if you don't actually account for these complexities. All right, the other one is time of use rates require us to know when electricity is being consumed or when gas is being consumed. And so, you have the complexities of a building system. Your heating needs are going to be dictated by climate, what you have your thermostat set to, the insulated properties of building envelopes. All of these things we've tried to capture at a very simplistic level, meaning like easy for a user to define. We've tried to try to capture these things in our tool. And one of the things that you'll note is, something that seems maybe straightforward at first to say, well, how does your bill savings change depending on your set point temperature? We're showing 3 curves here of what the thermal demand for space heating is across the course of a day. And, if your temperature is set at 65 degrees Fahrenheit, you may not have any on-peak consumption. So on-peak meaning that your electricity rates are high. But as you change that set point temperature, you end up with more and more consumption falling in on-peak rates. So being able to capture this sort of dynamic was really what we thought it would be very important given the complexity of the rates out in California. And Justin's already talked a lot about this, but just the idea that heat pump efficiency changes as a function of the outdoor temperature. And what that means is, you really need to do an analysis kind of like in an hourly basis, understanding what's the temperature, what's the outdoor temperature at the times that you're running an air source heat pump, to make sure that you're appropriately accounting for the efficiency. All right, so why does all of this matter? Well, if you're a consumer or an HVAC contractor, or a utility or a city, you're looking for the best information possible on what are the impacts going to be on people's fuel costs or energy costs. And in order to make good decisions, simplistic calculators may not be able to provide that for you. It's very likely that a simplistic calculator would result in misleading conclusions. And what I'm showing here is just an illustration of what happens if we do a bill savings calculations for different heat pump systems. And in one approach, we just use an average annual electricity rate. So that's what a lot of the simplistic calculators online will do right now. And if we compare that to our bill savings calculator, that's actually going to look at the complexity of rates and the time of use and tiered charges, you'll find that there's a big discrepancy between the bill savings estimates you'll get. So I think for anyone who's interested in electrification, the last thing you want to do is get kind of a negative reputation that somebody was told that they were going to save X amount of money and they ended up saving half of that. I think that's something that folks in this industry definitely want to avoid. So having tools that can accurately estimate bill savings is going to be very important moving forward in time. All right, for the sake of time, I'm going to skip over this. This one goes into a little bit of a wonky detail. But I just wanted to point out that another benefit of this tool is to be able to compare rates. So whether or not you're a consumer or a customer who's trying to figure out which rate should I switch to if I want to electrify, or if you're a utility trying to understand whether or not your rate structures are conducive or hindering electrification, we can run different scenarios through our estimator. Here I'm showing or comparing 3 different rates. One is going to be a 3-tiered electric rate with no time of use, another with 2 tiers and time of use, and the last one has no tiers, but it does have time of use. And what you see is that tiering is leads to fewer bill savings, and having no tiering is going to give you some of the highest bill savings. So really using this tool to understand the different implications of what rate you're on or what rate structure a utility might want to promote moving into the future, we can look at those sort of analyses with this tool. Okay, so summary. We now have this great website and bill savings calculator that we have initially focused on, Central Coast Community Energy's jurisdiction, but it's in a place where this is something that we could easily provide to jurisdictions across North America. And, with the hope of being able to provide consumers and HVAC contractors with more information and more accurate bill savings estimates. All right, that was a bit of a whirlwind tour, but I wanted to make sure we left a little bit of time for questions.
Thank you so much, James and Justin and Brian. It's very interesting to see all the work you guys have done. Yeah, so I want to open it up to questions. One quick note, we do send out a post-webinar survey, so please fill that out and provide your input. It's really helpful for us to provide you guys with useful information in future webinars as well. And we'll send out a lot of links for you guys, so you'll get this recorded presentation as well as links to the heat pump site and any additional resources that we have. And with that, we have a couple questions we weren't able to get to a little earlier, so I'm not sure if these were answered, but we're going to backtrack a little. This question is for Brian. Is there increasing interest in cooling in Fort Collins with climate change?
Yeah, that's a great question. I think, the electrification measures that we talked about today are ultimately going to be folded into our efficiency-based program, which has a history of, selling on essentially the health, comfort, and safety of building occupants. So we're seeing that more and more, and the messaging is going to kind of remain the same. I think 80% of residential premises in Fort Collins already have cooling. However, with two major fires over the past 10 years, in the High Park fire and Cameron Peak fire just west of Fort Collins, really exacerbate or accelerate the need for better indoor air quality during some of these disruptive events. So I'd say it's more kind of the indoor air quality and wildfire impact that we've seen.
Okay. We have another question, and I believe this was in reference to the Fort Collins model. Did the model assume no need to modify structure or electrical service panels and circuits when installing heat pumps?
So for the hybrid heat pumps, we made that assumption. There's no need to modify anything because you're just your baseline's an air conditioner, so the baseline stays the same. We did look at some options of including additional prices for service upgrades if you're going all electric. So that we didn't show any of those results, but we did look at those, and that does make things harder for the full electrification. Adds an extra couple $1,000s per premise.
Yeah, understandable. We have a question. This is for James. So the Lumina calculator is not available yet for utilities other than the Central Coast. Do you want to kind of speak to the availability on the heat pump calculator tool?
Yeah, so we completed the heat pump calculator tool this year, and the Central Coast Community Energy was the first utility to reach out to us. We're hoping to continue to expand the usage. I think it's a valuable tool, and realistically, it's from our perspective, it's pretty easy to update it for other jurisdictions. It just requires climate zone information, putting in new gas and electric rates, and kind of looking at the demographics, if you will, of the building stock and understanding what consumption looks like for an average or typical building.
Awesome. And Justin, you had mentioned speaking to Richard's question. I think we did get a pretty solid answer there, but I don't know if you had anything you wanted to add, maybe. Sorry, Rich's question on the related to modeling hybrid heating systems. Oh, you're on mute.
Thanks. So I would just mention that, yes, we didn't do that yet. We looked at just flat rates in the past. We are going to look at like the full set of sensitivities with this. So what's happening in different situations, and trying to also answer that question of, well, if you set things up with one switchover temperature and then things change, which in other parts of the country they've changed even faster than here. We would just want to know, like, are people going to suddenly start losing money because we gave them this piece of advice, or is it just that they're running a little bit less optimally than they would have?
Gotcha. Okay. I'm not seeing any other questions trickle in. So thank you so much for all the attendees for joining, for the speakers for joining, and talking about your use cases and what you're doing to reduce climate change and, greenhouse gases. It's very interesting. It's great to see so much thought put behind this all. So I really appreciate everyone joining us today. Yeah, thank you. Thank you so much.
Thanks all.
Thanks,
Have a
everybody.
great day.